Here we have a Vizio d55-f2 that won't turn on. Let's open it up and take a look. Before we dive into this, I just want to point out that this is a high voltage circuit, especially this half of it. It has the mains voltage here, and this capacitor can have up to 400 volts on it, so be very careful. Use the proper safety around these components. And because this is a very large capacitor, it can hold a charge even after the power is switched off. I'm going to hook up the power. And some of the things that you should check on this board first off is to make sure that you just don't have a blown fuse here. There's a fuse here. So that's the first thing you want to check. Then we can check the voltage on this capacitor. It should have close to 400 volts. That's pretty close to 400 volts. And that's indicating that the AC has been rectified down to DC onto your capacitor here. And this part of the circuit, the higher voltage part of the circuit, is probably working correctly. So now we're going to check the DC low power side, and it has an index here of what the voltages should be. The pins are labeled here, pins 1, 2, 15, and 16. So this row of pins is all the odd number pins. So if we look at the index here, pin 1 and 3 should be 24 volts. And pin 15 here is your power supply on. So we're getting 3 volts there, that's correct. So the way it works is the power supply sends some voltage back that way to the main board, and then the main board sends some voltage back here on this pin to turn on the rest of the power supply. So the way this power supply works is normally you have no voltage here, you just have the 12 volts. So for some reason the main board is turning on the power supply board even without pushing any buttons. So I'm going to unplug, instead of unplugging it here, I'm going to unplug it at the other end. So I'm disconnecting the main board. So we have the main board disconnected here. Now when we check this power supply on, it's off, which is correct. And if we check these voltages, there's no 24 volts there, no 24 volts there. And that's the way it should be when the power supply is off. So for some reason the main board's trying to turn the power supply on, but it's not. We can check, I have the negative hooked up to another spot. We can check to see if there's 12 volts. So that's on pin 7 and pin 9. So 1, 3, 5, 7. It's a little low, but it might be that the power supply is not, it's trying to use a low power state or something until the power supply turns on. And we can also check the voltages on this side if we want. You'll see there's no voltage here except maybe on pin 8 and 10. So it looks like we have this voltage here, which is good. This voltage here turns on when we plug in the main board. So I think the power supply here is good. The voltages are off a little bit, but I think that's probably because there's no load on the circuit. So I'm going to hook this back up, and we'll switch over to the main board and take a look there. Just on a side note, I just wanted to show you, I've unplugged this, the in there, the main in, and when we check the voltage here, you can see it still has voltage on it even though it's unplugged. So be very careful of those leads. Here we have the main board. This is the connector that I was unplugging. This is the connector that comes from the power supply right here. And I'm going to plug that back in, and I'm going to hook up the AC again. And we're going to just probe for some voltages here. So we know that this is just wire here, so we should have our voltages here. And if you look closely right here, I'll zoom in a minute, but if you look closely right here, this is fuse F4502 or 5401. And we have voltage on this side, no voltage on this side. So this is where the 26 volts is coming in, and that's where it's supposed to be coming out. So that fuse is shot. So the next step is to replace that fuse. So let's do that. I'll do that on the bench. So I was unable to zoom in and get both the fuse and the meter on the same screen. So what I've done is I've just set it for tone, and this is the fuse here, fuse F4501. And you can see there's no, there's no continuity through that fuse, so this is the fuse that needs to be replaced. So here I've got a donor board with a fuse I want to use right there, and we're just going to knock that fuse off with the soldering iron. I don't have a reflow station or hot air station, so I'm just going to use my soldering iron. Just going to kind of get it, try and get both sides at the same time with a bunch of solder, and we'll knock that off. Now the reason I've chosen this fuse is because it was available, but also it's a 5 amp fuse. Okay, to replace this fuse, you'll see that the fuse that I've chosen from my donor board is a little bit bigger. So what I'm going to do is I've actually taken another one that I removed from there, and I just put a little bit of solder on either side, and I'm going to add some solder to either side of the fuse that's in there. I'm not going to even remove that fuse. I'm just going to add another fuse on top of that fuse. And what I'm going to do is I'm just going to solder this fuse on top of that one. And this fuse is too big for this spot. So what I'm going to do, I'm going to get some different solder here. Solder has a little more flux. So I'm just adding some solder to either side of this fuse. Instead of trying to remove this fuse, I'm just going to add some solder to either side. And then we're just going to add that fuse on top. But you saw that I added the wire. I added the wire to this fuse, and I'm just going to, instead of trying to lay it down flat, I'm actually going to stand it up. Just going to bend the wire so that I can hold it at a better angle. So I'm just going to heat up the solder on the fuse that's there and the new fuse. Now that's on there, and then I'm just going to solder this wire to the other side of the fuse. You could also add, you can buy some of these fuses. They have nice long legs. This is actually a 2 amp fuse, so I'm not going to use it. But yeah, you could just take the legs of this fuse, put it on either side, solder that on as well. That would work just as good. But like I said, this one's a 2 amp fuse, so this one's not going to work because we need at least a 5 amp fuse. So I'll solder this on and then we'll try it in the TV. Don't need all of this wire. Just going to put a little bend on there. And then we'll just add some solder on there. I'm just going to heat that up a bit. Add a bit of fresh solder just to make it look a little neater. Yeah, that looks a little better, eh? So that fuse will work just like that. Let's try it in the TV. Okay, we have the new fuse in and the board installed on the TV. We're going to hook up the power and see what happens. We got the power light coming on over there. And look at that, the backlight's on. TV's powered up. So to fix this TV is a 10-cent fuse. Some of you may have noticed that I had these two tables up, and you may have also noticed that there's 24 volts or 20 volts. If you look at the bottom table, it would show you that depending on which board you have, you'll either have 20 volts or 24 volts, and you will also have 3.91 amps or 3.30 amps. So my board says that it should be 24 volts and 3.91 amps. Therefore, I chose a 5 amp fuse to put in there. If you found this video helpful, please feel free to share a link to this video on any appropriate websites. Thanks.